Hey all, welcome back. So in today's video, we are going to talk about something very important within system level, which is interprocess communication. Before going into what is this interprocess communication and all, as I told you before, this is very important topic in system level because when you are developing the test bench components within the system level, you will be coming under this particular topic like semaphores and mailboxes. So that is why interprocess communication is very important in system level. So don't skip this particular video and check out till the end in order to know what is this interprocess communication and what are the semaphores, mailboxes and events, and also why are we using this particular semaphore and mailbox components in our system level. So now coming to what is interprocess communication, from the name itself you can say that it is nothing but the communication that is happening between the processes, or the communication that is happening between the test bench components within the system area. Right? Process is nothing but we have already talked about these processes in our videos. Like we have seen three kinds of processes like fork join, NEM, fork join, none. Okay, so the communication that is happening between these processes is nothing but inter-process communication, or the communication that is happening between the particular components in test bench. Like you already know when you have, I think you have already seen about the test bench architecture, SP test bench architecture. I have already explained about the SP test bench architecture. If you don't listen to that, I link that particular video in the description box. You can go there and check it out. And when you see the system level of test bench architecture, you will find lots of components within the system level of test bench architecture, like environment, monitors, scoreboard. Okay, so in this way, driver, okay, DUT, in this way, lots of components you will be seeing within the architecture. So when the communication is happening between these components, we will be using the semaphores and mailboxes in order to communicate between one component to another component. So for this we have to definitely know about this semaphores and mailboxes. If you want to build a test bench architecture in system Verilog or UVM also, you should definitely know about this particular concept, which is inter-process communication, right? So don't skip this video and watch till the end in order to know what are semaphores and what are mailbox and events. And before going into the channel, if you are new to the channel, consider subscribing this channel and hit on the notification bell also. Right? Now coming to semaphores. So basically, as I told you, this is nothing but we are using this particular interprocess communication in order to in order to have a communication between the processes, like in order to know what is happening between the processes. So for this, let me explain small thing for you before going into why are we opting for this semaphores, like why are we using this semaphores. Before going into this, let me give you a small example. So basically, okay. So, for example, let us think that we know about what is fork join, right? So, within fork join, whatever processes that you are using within the fork join, so all will be executed parallelly. Is it or not? Either we are using functions or tasks, whatever process is nothing but it is a method. Okay, methods are nothing but functions and tasks. So already know that. So whatever process we are running within our particular forejoin thing, all will be running parallelly. That means everything will be starting at zero time interval itself, but based on the delay we are using, they will be happening between. If we don't give any delay, everything will be happening at zero delay time itself. Now, for example, we are writing the code. Okay, we at this particular point of time when we are having two processes. Okay, and these two processes are using the same memory location. Okay, got my point? Let us consider we are running two parallel processes and both these processors are using the same memory location. Now, one process want to read something from that memory location Another process want to write something into the particular location. But as I told you, both of these things are happening at the same time. That means both reading and writing should happen at the same time. So is that possible? No. Okay, reading and writing never happen at a time. First you can read it and then you can write it, or you should write it and then read it. Okay, but both things doesn't happen at same time. But since we are going for process, so process will be starting, everything will be running parallelly. So according to our concept, both of them should happen at same time. Now what happens, because of this mismatch, you will be getting the error in your particular code, or you will be reading something which is not that thing you want to read, or you will be writing some error into that particular memory location. So in order to avoid this particular situation, that means in order to avoid a particular thing where when both processes are happening at same time, so in order to avoid this particular thing, we are opting for Semaphores concept. Okay, got my point? C. Semaphore in system Verilog is a built-in class used for access control to shared resources. That is what I told. When two processes are sharing the same memory location, so in order to access that particular control, in order to have a control on that particular running, we are using this particular semaphore concept. Okay, in system Verilog, various processes can run in parallel, as we already talked. Okay, this can create a problem if two processes access same variables. Okay, so that means when they are accessing the same variable at the same, two processes are accessing same variable. That means when two processes are sharing something from the same memory location. Okay, semaphore provides a solution to this problem. Okay, clear. Semaphore is basically a way to avoid unintended access to shared variables. Okay, so in order to avoid this unintended access, that means in order to avoid this reading and writing happening according to our example that we have talked now, in order to avoid both the things like reading and writing happen at the same time, we are going to use this semaphore. Okay, got my point? So this is how we are going to use the semaphore. Now let us see what are the things that are there in the semaphore. What are the methods that we see in the semaphore? Okay, there are four methods in the semaphore. One is new, another one is get, another one is put, and then try get. So these are the four things. Only four methods you'll be having in your semaphore, right? New, as you already know what is new means, I don't want to again explain it. So in order to create a semaphore, okay, you will be using this new. Okay, so in order to create a semaphore with specified number of keys. Okay, so in order to easily understand for you, I will just tell you this to you in a simple manner. Okay, for example, you are having a lock. Okay, every lock will be opening with a key. Is it or not? So semaphore is nothing but a lock with a bunch of keys. Okay, so in order to create that semaphore, you need a keys. So in order to have that keys, you will be using that particular new keyword. Okay, if you want for four number of keys, you will be giving that new of four. That means four keys will be created. Okay, clear? Yes. So new means in order to create the keys for that particular process. Process here is nothing but a lock. A lock with a four keys. A process with four keys. Clear? Now get. So since there are keys, get means when you want to have the keys, you will be getting those keys. Okay. So among these four keys, if you need only two keys, then you will get only two keys. Okay. Right? Clear? So put. So after getting the keys, you again need to give the keys to that particular person. Okay, clear? So after getting it, you need to put it back, right? So from where you are getting, you need to put it back, right? And try it. Try to obtain or get specified number of keys without blocking the execution. That means what is happening here is basically, as I told you here, there are for example, let us consider in new I have created four keys. From get I have taken the two keys. Okay, now with target I can get only two more keys because there are only two keys left. But if I want three keys with the target, that is not possible because there are only two keys remaining in the new. So if I want to get the two keys, I can get it by using the target. But if I put it, then I can get four keys. Okay. But if since I didn't put the keys again back there, so my new consists only two keys, and with target I can only get those two keys without blocking the execute. Clear? So this is what these four methods are used. Okay. So for this, let me explain this within the example for you so that it will be easily understood for you. Like what is the reason of using the semaphore? That we have talked in entire theory way, like this process blocking and all these errors, everything we have talked in a theoretical method. Now let us explain this in the example method so that it will be easily understood for you. So if you see the example here, okay, module semaphore. So in this, if you see, I am having two tasks, so nothing but two process. Okay, so within one process, my process name is task write memory. Okay, so within this there are two display functions. So in the first display function, before writing into memory, and then I have given 5 time units of delay, and I have written another display function write completed into memory. Okay, now with this is my first process. Coming to second process, first at 0 time, here if you see both are at 0 time display only before reading into memory from memory, and at 4 nanoseconds read completed from memory. Fine, and returns. Now within initial begin, see within the fork join, I am starting both these process. I didn't do any delay here. So both will be running parallelly because it is fork join. So whenever you are mentioning anything within this particular fork join, any fork join none, everything will be run parallelly. So that means both write task as well as read task will be running parallelly. Now what happens after running parallelly at 0 time unit, since there is no delay, this will be displayed first. See, at 0 before writing into memory. Now similarly at 0 before reading into memory. Okay, clear? Both are at 0 time only. Now if you see here, this is at 5 nanoseconds, but this is at 4 nanoseconds. Now what happens? First, since this is low time unit, so at 4 nanoseconds, read completed from memory, and then at 5 nanoseconds, write completed into memory. Now, if you see the output here, is it somewhat if you see the output here before writing into memory, before reading into memory, read completed and then write completed. Without writing anything into the memory, how could you read it? Is it or not? Right? Did you get my point here? Is it somewhat weird here? Because before writing into memory, how can you read it? But first the read action is completed before writing something. So what is it that is being read then? You didn't write anything into the memory, but the read action is completed. That means there must be some garbage value or some unknown value into that memory. That particular thing is read. But what is you want to read, you didn't read it. Okay. What so your task is not completed here. But what you don't want to read, like some garbage values there, it has read that particular thing and it has said, yes, my action is completed. But this is not that you want, is it or not? So here, what is the output that you want? You want to write it and then you want to read it. Okay, but in this particular time only you want to do that. For this particular code only, now if you want to make this correct, what you can do is you can use the semaphores. Okay, now for this same example, let us see how the semaphore is used. Now if you see here semaphore, okay, as you already know, semaphore it will be created by using the new. Okay, semaphore with its name sem equal to new of, I have taken only one key. You can take any number of keys you want, but I have taken only one key. That means I have created, not taken, sorry. I have created only one key here. New means for creating the key. So I have created only one key. Now, if you see here, okay, these are my two tasks. Okay, for every task I have created sem dot get. So this is my semaphore. I am telling it to get. Okay. Now, if you see the everything is same. Like if you see here, except that sem get and sem put, everything is same here. Display 5 nanoseconds, display, please see here, display 5 nanoseconds, display 5 nanoseconds, display 4 nanoseconds, display. The only thing I have added is I have created a semaphore and I have used the options methods like sem.get and sem.put. And if you see here, 4 within the fork join, write memory and read memory has started. Now both will be starting at 0 time only. Okay. Now first task write menu. Okay, sem.get. That means it is getting what it is getting. It is getting the key. Since only one key is created, so that key is given to this write memory. Okay. Since write memory is getting it, so there are no more keys. So read memory don't get anything basically. Okay, because I have created only one. Two persons have came to me asking this. I will be giving my key to the first person who have come to me. So this first person came and took the key. So even now the second person come also, he have to wait until the first person give me that key. Is it or not? Right? So the first person is write memory. Write memory has come. He has took the key from me. Right? So until he give that key to me, that means until he put that key to me, I can't give it to the second task. So that means until when will it put, until all this until all the display will be happening here, then only the sem.put will come. So here first, before writing into memory, then it 5 nanoseconds write completed. Then after this it will be putting that key. That means that right person will be giving me the key until this, after completing these two things. Now sem.put. Fine, completed. Now, since he has given me that key, that means until sem.put is given, I can't do anything. But after sem.put, I can use that to again read memory. Okay. So that means I have given the read person my key here. Now what happens? Now at same 5 before reading from memory. Okay. And then 5 plus 4 at 9 read complete from the memory. Okay, and then again sem.put if there are any other tasks, and then I will be giving the same key for all of them also. Got my point? So this is how you will be using the semaphore within your Verilog. Sorry, system Verilog, right? So this is how the keys. For example, if you are creating more than two keys or more than one key, then you can use both of them at same time. That is another case. Okay, I'll explain that also in the upcoming classes. Don't worry about that. But as of now, you just remember that semaphore is used in this way. Okay, basically it is everything is based on sem.get and sem.put. Okay, if you are getting it, until you are putting it, no other one can get it. Okay, you should just remember it in this way. Hope you are clear about the semaphore thing. And if you are still having any doubts on the semaphore, you can ping me in the comment box. I'll definitely answer your questions. And also, before leaving the video, please consider subscribing the video and click on the notification bell also. Also, forward this to all the VLSI aspirants who also want to enter into design and verification domain and are learning this very well system with your. That is all for today. Thank you all.